divide by 0, so you're going to say, let's let the denominator 2x minus 3 equals 0. What x value makes it equal 0? Add 3 and divide by 2, x equals 3 halves. 3 halves will not work in my domain. Sure, I can do 3 halves squared and add 4, that's fine. But when I put 3 halves into the denominator, it'll be 2 times 3 halves, which is 3. 3 minus 3 is 0, and then I'll get something undefined. So that's not going to give me an answer. So for my domain, I'm going to say x does not equal 3 halves. Everything else is fine. I can divide by negatives. Oh, maybe this is what you're referring to, Delaney. I can divide by fractions. I just had to multiply by the reciprocal. That's what you were talking about. Yeah. But it would be okay if the denominator was a fraction. Like, it doesn't matter, I can still get an answer. What I'm looking for is when I can't even get an answer. Okay, now on the second one, f divided by h, let's set x squared plus 4 equal to 0. X squared equals negative 4. And what happens when you square root both sides? You would get like x equals plus or minus 2i. But when we're talking about domain, we're really talking about the set of real numbers. So like we can't put negative 2i in for x, we can't put positive 2i in for x, but who would ever think to do that? So we can say in this one, the domain is not restricted. Like all real numbers will give me an answer that's not 0. There's no way that you can put a number in for x, square it, and get negative 4 unless it's imaginary. So all real numbers are going to work in this particular division. So if you see division, maybe you need to write this down like up at the top with the rules. Okay? If you see division, there may be a restriction to the domain. Check your denominator. So we'll say check denominator for restriction to domain. And you can do like I did, set the denominator equal to 0. See if there's an x that makes that happen. If there is, you need to like leave it out. And I guess we could also say, maybe somewhere up there where all your notes are, make a little note to yourself. If there is an even root, you may have a restriction to your domain. Okay. So we saw in the example when we were using the one with the raised to the 1/2, x to the 1/2, that was a square root. So then we always had to say, if we ended up with x to the 1/2, that x had to be greater than or equal to 0. So if you have an even root, you might also have a restriction to your domain. If you have an odd root, not going to be an issue, right? Because we can do odd roots and negative numbers. We kind of tackled that again yesterday when we were working with the inequalities. Okay, I can odd root negative numbers and not have an issue. So I have the same 4 problems. I'm going to go through these a little bit quicker just so that you get a chance to work on your homework. But these are the same 4 functions, right? So you don't have to rewrite the functions at the top. Let's just start with g, j. That's hard for me to say. G times j of x is what that says, right? So this is a multiply. I'm going to take g, which is 3x to the 1/2. I'm going to multiply it by j, which is 9x to the 1/3. If I'm multiplying 2 functions, check to see if anything can be simplified. Well, I could multiply 3 times 9, that's 27. Can I multiply x to the 1/2 times x to the 1/3? If I just had this on your Test or quiz, x to the 1/2 times x to the 1/3. Can you multiply those? Yeah, how do you multiply powers that have the same base? Yes, you change the exponents so that they have the same denominator because you're going to do what with the exponents? Add them. You add the exponents. Keep the base. Add your exponents. So like Maddie said, get them to have the same denominator. That would be 3/6 plus 2/6. And this will be 27x to the 5/6. Right, they're not connected to 3 and 9 at all. So then I could multiply 3 and 9 together. And then the x's, like I wrote over here on this sideboard, they look like this. And what you should see is they're both powers, a base and an exponent, and the bases are the same. So this, now you see like, why do we learn those silly properties of exponents at the beginning of the chapter? Because now we can combine the functions. So if we multiply them, we should, with the same base, we should add the exponents.
So like if there were parentheses around the 3x and then the 9x, then you couldn't do it.
I couldn't do it because the 1/2 would have a base of 3x, the 1/3 would have a base of 9x, and those bases are not the same. Good questions. Excellent. Think about domain on that one. Get that fraction exponent. Where is your root? In the denominator, so you have a 6th root. Can you 6th root anything you want? Nope, can't 6th root negative numbers. So domain is x greater than or equal to 0. Okay, because that's really a 6th root problem. This is Miss Crocky. Oh. Okay, sure. No, you're supposed to go to the office with your car keys. All right, g plus j of x. So now we're going to add those two, right? 3x to the 1/2 plus 9x to the 1/3. Can you add those? No, in order to add stuff, doesn't everything have to be like terms? Like you can't add x squared and x. So you can't add things like x's with different exponents. Doesn't add. So this is as good as that one gets. Not very good. Check your domain. You've got a square root and you've got a cube root. So the square root is going to restrict you, right? Domain is going to be x is greater than or equal to 0. You know, I could put anything I want into this cube root. I wouldn't have an issue. So if it was just the cube root in there, I would say all real numbers. But because I also have to be able to add it with something that I'm doing a square root of x, then it has to be greater than or equal to 0. All right, and the last one we'll do the composition of g and j. Okay. Oh, I'll just do g and j and then we'll call it good. G and j. All right. G was the 3 one. And I'm putting j, 9x to the 1/3 in for that x. Okay. So g of x is 3x to the 1/2, but we're replacing x with j, which is 9x to the 1/3. Okay, on this one, I could do a little bit of simplifying. I can raise 9x to the 1/3 to the 1/2. That would be 3 times 9 to the 1/2 times x to the, what should I do with these two exponents? Power of a power. Multiply them. You see how that's different than this example over here? I'm not doing x to the 1/2 times x to the 1/3. I'm doing x to the 1/2 raised to the 1/3. And So if I ignore the 9 there, it's x to the 1/2 raised to the 1/3, and then I multiply my exponents. But notice on this one that if you have something that's being multiplied inside, it applies to that 9 as well. What is 9 to the 1/2? 3. So this is really just 9x to the 1/6. Cool. That looks pretty good. And because I have a 6th root, domain is x is greater than or equal to 0. It's an even root. So it just depends on what your functions are made up of, what's going to actually happen with your domain at the end. I think on the homework, if you look at the very top of the page, it's going to tell you which ones I want you to do domain for. Okay, so I don't think you have to do domain for all of them. Everybody gets this? And I'll repeat. Okay, so notice at the top it says perform the function operations in state domain for number 1, 3, 6, 9, 10, and 11. So if you want to like star or circle those or make a little note to yourself, domain, those are the only ones that I'm going to require you to think about the domain for. There is a backside. I love number 13. That's a really great question. And then there's some review at the bottom, which will be good as we start prepping for our Chapter 5 test next week. And I will let you get started. We've got about just under 10 minutes. So work and ask questions if you have them. Give me 1 second.